Okay, we are live. Hi everyone, happy Monday. Welcome to our show today. It's glad to see people here and today we have Matt and Bryan join us. So would you guys start with a self introduction? Matt, you're mute.
Yeah. All right. Yeah. Hey, everybody. Matt Fenwick here from Synopsys. And let's see. Yeah. So I got involved with network policies a couple of years ago with Jay and a meme end-to-end testing. And so I'm going to be showing you a project that kind of spun out of that stuff. So nice to see everybody that's here. Yell at me on the chat or something. Say hi.
And I'm Bryan Oliver. I'm a principal at ThoughtWorks. I've started contributing to the network policy API recently in the Kubernetes SIG network project, and decided to jump on trying to write conformance tests for the new admin network policy. And we felt that Cyclonus might be the right tool to do that. And I have no idea how Cyclonus works. So asked Matt for a deep dive, and we decided to make it a live YouTube video in the process. So I know about as much as the rest of you about it. I'm going to try to ask questions while we're live, and then also feel free to add more questions and comments, because I'm sure I won't ask everything.
Yeah, if you ask the questions and comment, we can see that in real time, and maybe we can answer that during the show. So for everyone who are first to the entry live, please log into your YouTube account so that you can leave your questions and comments. Okay, so cool. Shall we start it? I'll hand over to Matt from here.
All right. Sounds good. Thanks, Xinqi. All right, everybody. Xinqi dropped a link to a markdown in the chat if you want to check that out. That's kind of the rough. There's a couple of points that I want to hit, but I don't want to monologue. I don't really want to give a talk so much as I want to, really like dive into the code and help everybody understand what's going on and stuff. So Bryan is your advocate. If there's things that you want to talk about, you have to convince Bryan to yell at me to make me talk about those things. If I'm getting off topic or like boring you to death or something like that, just tell me that, you're getting bored. So let me see if I can share my screen. I think I did the permissions right. I promised Xinqi that I would. Okay, let's do the entire screen. Okay, is that working? StreamYard is sharing your screen.
Yeah, we can see your screen.
You good?
All right, cool. So I should be showing everybody the walkthrough right now. All right, cool. Yeah, looks like that's coming through. And let me just spend a few minutes giving an overview and talking about what this looks like from the user's point of view. And then it's kind of over to you, Bryan. I have some stuff that I think might be interesting that we can talk about. But if there's other things that you would rather talk about, then feel free to start like telling me what to do.
Okay, sounds good.
All right, yeah. So basically, Cyclonus is a tool that I built with some help from some of my upstream friends from VMware and a few other places. We have a blog article that you can read about where you can learn about the origins of this. Jay Vias is kind of the guy that got me into this. So if you need more context than what I can provide, then I think Jay would be the best person to tell you about where all this stuff came from. But basically, when I started working with Jay, he showed me this really cool idea that he had for network policy conformance tests on CNIs. And the secret sauce to that was that he had a way to visualize what a network policy is that was very concrete. So we spent some time putting that into Kubernetes. So the network policy tests are now using Jay's idea. And once that merged, so first of all, we have a blog article somewhere. I know I linked it in this document. I think Xinqi also shared it to the chat, so you can see our Kubernetes blog article.
This one.
Yeah. Okay. Cool. Awesome. So we got that stuff merged, and then we were like, okay, cool. For each of those test cases, if you look at the code, you have to like manually define a table of all the connectivity. And I'll show you an example of those tables and stuff. What Cyclonus adds is it takes those end-to-end network policy tests and it adds a network policy engine. So you give it a network policy or a group of policies or whatever, and it will tell you, like, is this traffic going to be blocked? Is this traffic going to be allowed? And so on. So that's one thing that it adds. And then the second is, I guess you could say, like, maybe step one on the path to a network policy fuzzer. So maybe not like a real fuzzer where you're just generating thousands and thousands of random tests, but it does do at least over 100 different network policy tests that explore all kinds of different areas of the semantics of network policies and stuff. And you take the, I guess I call it generator, that generates a bunch of network policy tests. You take the engine, so that tells you what the network policy test means. And then you run those on CNIs and you can see, okay, is my CNI actually doing what I expect it to do? And then also from a human point of view, it will show you, what does your network policy actually mean? So I know that's all super abstract and stuff. Let me stop monologuing and start getting a little bit more concrete here. Yeah. So let's talk about connectivity truth tables real quick. And again, this is the idea that, as far as I'm aware, Jay came up with. If somebody else came up with that, please yell at me in chat. Oh, and I see a meme was just asking about the date that we published this. Yeah, this was posted 420 meme. Thanks for bringing that up. Yeah, so we were talking about the whole idea of visualizing a network policy. What does it mean? And the idea behind tables was, let's talk about what pod can talk to what pod. So in the blog article, you can see this right here. Going down on the left, I think we have like source, and going across on the right, we have destination. So for a dot, I think that means a pod can talk to another pod. And then if there's an X, that means a pod can't talk to another pod. So the idea is, I'm sure we're all kind of aware with ways that network policy is a little bit confusing in terms of syntax and semantics. So let's talk about what can talk to what. And this table is a great way to be able to visualize that. So let's say you block by one specific namespace. I think that's what we're seeing here. Block everything, I guess, going from one namespace. So egress from namespace X is blocked, and this is what the connectivity table looks like. So now all of a sudden you have a really concrete way to think about network policies. We'll come back to that in a little bit, probably, I assume. So that's one part of Cyclonus. And then I told you about our network policy engine. So like executable network policy specification is kind of the way that I think about that. And then the third part, you can generate a whole bunch of network policy tests. All right. Remember to shout at me if you have any questions or something, or shout at Bryan or something like that. Bryan, do you want me to cover anything, or are we good?
I did want to touch on the truth tables for a minute. Is there ever a situation where you are building the truth tables from scratch, or are those always going to be artifacts that you get out of different Cyclonus runs?
Yeah, that's a great question. So if you want, this might be a good time to jump into a test run.
Okay.
That sound good to you?
Yeah, sure.
All right, cool. So the basic idea behind a Cyclonus test run is you have a network policy or a group of network policies. They can be any network policy that you want. And what we want to know is, from the point of view of Cyclonus, is that network policy implemented correctly by your CNI or not? So we need two pieces of data for that. What is it supposed to do? And what does it actually do? So to get what a network policy is supposed to do, that's where we have the engine. So parse up all the network policies, create some model of that, and then we can query that model to decide, is traffic from one pod to another pod allowed or not? So that's one piece of data. And then we need to compare that to actually spin up a cluster that has the CNI that you're curious about, whether that's Calico or Antrea or Cilium or Oven Kubernetes. Those are the four that I use. That's why I'm mentioning those. If anybody wants to shout out some more CNIs, let me know. But yeah, actually spin up pods that have labels on the cluster and get some traffic going back and forth, see if traffic is blocked or see if traffic is allowed. And I can dive into the details of how exactly we collect that in a second, but that's the core of Cyclonus. So you actually have two tables, your expected data and your actual data, and you compare those and you get a diff, basically. Like, am I doing everything that I expected, or am I seeing something a little bit different? So with that as the context, then we can jump into this document. Maybe I can go through this in a couple minutes. Let's see. So here's our resources. We have 3 namespaces and 3 pods. Namespace X, pod A, pod B, pod C. And of course, because you can't target namespaces and pods by name, or at least you couldn't when I wrote this a couple of years ago, we label everything. So every namespace has a label NSX. Every pod has a label, pod A, whatever the name of the pod is. So you can target it uniquely.
Which you'd see in a normal network policy anyway. Targeting via labels is fairly common, right?
Yeah. And then we're running 4 servers on each container, I think. Is that right? Let's see. So we have port 80 on TCP, port 80 on UDP, port 81 on TCP, port 81 on UDP. I'm not sure why. There's something weird with this output here. I wonder if this is saying that we have both named ports and numbered ports available, because you can target both of those for network policies. But anyway, each pod has 4 different servers that it's running, 2 protocols and times 2 ports. And you can see we have pod A, pod B, pod C, and then hop over to namespace Y, pod A, pod B, pod C, namespace Z, pod A, pod B, pod C. So that's 9 pods, and then 4 different ports per pod. So basically we have 36 different targets. You might be wondering, why do we have 3 namespaces? Why do we have 3 pods? The way that I think about it is that if you just do 1 pod to 1 namespace and you just check whether there's connectivity or not, that was the old way of the Kubernetes upstream network policy tests. And you just don't really, you're like looking through a pinhole at a large amount of data. So maybe you get the right connectivity between one group of pods, but is your policy really doing the right thing? What about all the other stuff that you're not looking at for that one specific connectivity test? So by collecting a lot more data, now you have multiple different namespaces. Now you have to ask yourself, are you doing the right thing not just for one namespace, but for all namespaces, including ones that you're not trying to target? Are you doing the right thing for one pod or for all pods? Are you doing the right thing for one port or one protocol, or for all ports and all protocols? So that's why there's multiple things there, but obviously that means a lot more data to collect and a lot more data to think about and stuff. So there is definitely a cost to having those additional pieces, but there's a benefit of you get a lot more context to see what's going on. And there were a few bugs where that did end up being pretty useful. So it wasn't just like a totally academic, let's collect a whole bunch of data for no reason kind of thing.
You mentioned name ports, by the way. This came up in a recent community meeting that I guess there's a reason why name ports are preferred. Do you know anything about that?
Oh man, I don't think I'm the right person to answer that. If anybody is in chat and wants to yell at us for that, I'd be kind of interested to hear that too.
Yeah, it came up as a recent GitHub issue in the SIG, and I was we didn't have time to get further into it, but I was like, I wonder why that's a recommend. I'm sure there's a reason, like maybe for testing purposes, it makes it easier, or easier to audit network policy. I'm not sure, but anyway, sidebar.
Oh, I see Kalen. By the way, hi Kalen, hi Scott, hi Matt. I don't know if you're responding to what me and Bryan just said, but yeah.
I think it was Kalen's issue actually that came up. We're trying to get CNIs to recommend or to push, or we're trying to find a way to get them to push for named ports, like auditing and understanding. Okay, that's what I thought. That makes sense.
Gotcha. Awesome. Yeah, thanks, Kalen, and nice to meet you. All right, yeah. So let's jump in to continuing this test case here. So Brian, I know you're asking about this. I guess everybody looking at Cyclonus will notice that I just absolutely love tables. There's this project called Table Writer or something like that, and I ended up putting pretty much every piece of output through that. I don't know if everybody else likes tables. If you do, let me know. If you don't, just tell me that I'm stupid or something. But you can see, basically, I love tables. You can see that I use tables everywhere. It's a great way to organize stuff, in my opinion. So the first table that we have, actually, no, this is the second table. The first table was the resources that we're putting in our cluster. The second table is an explanation of what our network policy means. So why is this necessary? Well, I guess if you can look at a network policy and perfectly understand it without, having any kind of assistance or tool or something like that, you don't need this. But that's not the case for me. Like there's really subtle corners to network policy, syntax, network policy, semantics. You can even see that in the Kubernetes docs. So that's why I found it useful to print out what's my understanding of the network policy. And I guess that turns into Cyclonus. So, break things down by ingress, egress, tell you what the target is, link it to a source rule in case you need to figure out that connection. And then you have this concept of peers built into network policies. You can either have label-based peers or you can have IP block-based peers. And then what port, what protocol are we talking about? So for this network policy, we are allowing ingress to these pods. We have a little IP block, and it's just port 80 that we're allowing. And then we have a couple of egress rules as well. And here's the source printed out down below. All right, now we get into those truth tables that we were talking about. And we're actually doing things on multiple ports and protocols. So we're querying on 3 different protocols, SCTP, TCP, UDP. By the way, shout out to a meme for getting a lot of this stuff working with some of these protocols. I think SCTP and UDP, I think that was all a meme to make that stuff work. So hat tip to a meme. We're also collecting data on 2 different ports. So that means for each pod, from each pod to each pod, we are collecting 6 data points. So like this would be, we're going from XA to XA. So like a loop back or hairpin, I guess is the term for that. SCTP 80. So this is telling us is SCTP is blocked on both ports. TCP 80 is open. And then TCP 81 plus UDP 80 and 81 are blocked. Whereas if we're going from XA to XB, everything's open, 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 open. This is what we expect, but just from an ingress point of view. This is what we expect from an egress point of view. So you can see we actually separate out what the ingress and the egress policies should do. And then we combine those into, this is the connectivity that we would expect to see in a Kubernetes cluster. So how do network policies work? I think that you have to both allow ingress and allow egress. So basically that means, we superimpose this on this. If both of them are dots, which means they're both allowed, then we get a dot for combined. If either one is an X, then we get an X. So if one allows and one blocks, then we block. And this is the table that we get from that superposition right here. Is that kind of making sense? Did I say anything dumb there that I need to go
No,
back?
that makes sense. I was wondering in this run here, was that source created by, say, you or somebody that wanted to run a policy, or was Cyclonus actually generating this policy that was then executed and tested against?
I believe this is probably something that I took from a Cyclonus run where it generated a bunch of different policies, did a bunch of different things. And this is one of the things that it did. And I think I just copy pasted this output into the document here.
Okay, makes sense.
All right, yeah, so we end up with the expected connectivity. This is combining ingress and egress. And down here, this is the actual connectivity that we saw on Kubernetes. And you know what? I don't know how I collected this data, but since you can see everything is allowed. So I'm guessing I probably was just like running on kind with no CNI or something like that.
Probably, yeah.
Probably did something dumb. I don't think there's any CNI that would that would give these results. But that's okay, because that's not the point of this test. This is just to make sure we're make sure we're understanding the test results. So the last thing that we get is we compare actual to expected. And you can see we have 6 data points up here. I guess we could have broken that comparison out so there would be 6 data points per pod from pod to pod down here. But I just decided if any of those 6 is wrong, we'll put an X. And since apparently I didn't have a CNI or whatever, none of the policies are implemented, so nothing is getting blocked. So basically, if you look at our expected data, everywhere there's an X, we're going to get an X in the final output because I'm not blocking any traffic at all. So what this is telling you, you have problems here, and then you have problems here. So whenever the source is XA, whenever the destination is XA, at least for this network policy, we have a problem. And then of course, all of these dots, these are correct, at least from the point of view of this network policy.
So if I set up a brand new cluster through Entrea on there as the CNI, then this is probably the same output I would get without any network policies at all. If I were to run this test, then I would probably get the similar output, right?
Let's see. So if you had Entrea running, you should see things happen correctly.
Mm-hmm.
So I think in this case, like I had network policies, but I didn't have anything implementing the network policies. Like I didn't even have Entrea or Cilium or Calico or whatever.
Okay, I got you. So Cyclonus has actually got a set of network policies in this run that it was testing against, like IP block as conformance for IP block based policies, and then we would have seen a different table. Is what you're saying. Yeah.
So going back up here to the resources, like Cyclonus will create pods on your cluster, but it won't create a CNI for you.
Right.
I mean, you can see that there's scripts in the repo where we install Entrea and stuff like that, but that's really outside of Cyclonus. Cyclonus basically, it doesn't do any cluster. It just, I think it's ping each other, but CNI or something like that, then Cyclonus is just going to happily tell you that your network policies are totally broken.
Right. Okay. Gotcha.
Let's see. Did we get to the end of this document? Yeah, I think we pretty much covered everything here. So you might be wondering, how exactly do we get these different things to talk to each other? And this is another thing that we have to thank a meme for. There's this container called AGN host, or this image called AGN host. I can't remember what that stands for, if it's agnostic or network tools or something like that. But it has all these tools to run SCTP servers, to run TCP servers, to run UDP servers, also to run clients for all of those different things. So we set up all of these pods, and they're all running servers, but these pods are based on an image that includes tons of networking tools, so they also act as clients. And then basically what we end up doing is something like a kubectl exec into these pods to have each pod ping all the other pods. And if we dig into the Cyclonus code base, we could find out what exactly those tools are. But I'm pretty sure they're all in the AGN host image, which is just a ton of networking tools. And yeah, thanks, Amim. Oh yeah, Project Entrea says thanks, Amim. Yeah. All right, cool. So that's a test run. We can definitely go into more depth there. Let me just look at my notes real quick and see what else we have to do. I guess that's.
I do want to dig into generate at some point, but I want to make sure you get through your what you have down first.
No, I'm pretty much at the end. I mean, we can just briefly mention the CLI for a couple minutes, and then we can hop over to your stuff. Yeah, let's do that. So there's 3 commands. There's a CLI for Cyclonus, and there's three major commands. Cyclonus analyze is basically an interface to the network policy engine. So we have a whole bunch of examples here. Let me know if you want to go into more detail on these. But here's the different things that you can do with analyze. You don't need a Kubernetes cluster for this. I don't think it's doing anything with Kubernetes. It's just all happening in Cyclonus itself. The idea is to provide a suite of tools that help you understand concretely what network policies do. So like you can create JSON files, and you can see that I'm linking to a bunch of JSON files here to describe pods in your cluster, put labels on them, expose ports and protocols and stuff like that, and then do like fake queries or like fake traffic. So that's what's going on here. Query target, query traffic, that tells you different things about these network policies. I don't know how useful these things are. Like I found them kind of cool and stuff like that. I guess if everybody else thinks they're dumb, then that's cool. If everybody else thinks they're useful, I'd be really interested to hear about that. I think Kaylin was asking about these a couple days ago. So maybe I would love to hear more about your use case, Kaylin, at some point, because that sounded pretty interesting. I know you're thinking about this.
Well, like that was the ability to simulate a network policy issue that I think I mentioned it to you. I think you ended up jumping on that, so that was good. This Analyze could be a good case for that. I was also thinking about how developers could potentially use Analyze to try and develop network policies for their own use cases that might be useful, or maybe even in a CI process somehow. Be a little trickier in the CI process because you'd have to make sure the output is usable and comparable, but could also be pretty cool.
Yeah. Definitely.
So on the generate side, I wanted to maybe get an overview of just a general overview with generate, like how to start using it, how to start thinking about working with it, and then maybe how it works under the hood.
Sure.
See how far that takes us.
Yeah, I guess we can just start hacking on this. How's that sound?
Sounds good.
Let's see. Oh, I guess two other things I want to tell everybody real quick. First of all, there's a kubectl plugin under Crew.
Oh, yeah.
I think everybody's probably familiar with Crew. You can see the code under. What is it? Can't type. Sorry. Here we go. Yeah. Can I link this to everybody?
Yeah.
Oh no. Sorry, I'm watching the video at the same time as I'm talking. That was pretty
created
weird.
The infinity realm.
Sorry, everybody. So that was one thing. If everybody wants to try things out through the plugin, the other thing is that this was just upstreamed into the SIG network policy project. Do I have the link to that somewhere?
It's k8sig/network-policy-API.
Oh, you talk so fast, Bryan.
All right. I didn't log into Shipyard, so I can't link it. Hold on. I'll send it to
my
you.
Notifications. SIG network policy API. All right, yeah. So this just got merged in up here. I don't know if Andrew is around, or I'm not sure whose name is TS Surya. I think that was the person who did that. So Cyclonus is in a state where like we have the old repo under my personal one, and then it's been copied over, but it hasn't really been totally adopted upstream yet. So definitely looking forward to working with the community to help you adopt Cyclonus, and figure out how to make it as useful as possible for what you need to do. But
yeah, we were talking earlier about like putting a build process in place for the Cyclonus images and binaries and all that from this repo. We'll probably be opening up some issues that people can jump in as good first issues there.
All right, cool. Now let me stop wasting time and get into the good
stuff. You're good. Getting more people involved is never a waste of time.
Yeah, so if you pull down that plugin, then I think it would just be like kubectl Cyclonus generate, and I assume everybody probably uses Cobra for Go. Mm-hmm. I just love Cobra because it gives great help and stuff. So you can just throw a -h on there and you'll get all kinds of nice help. So the basic idea behind generate, I know it's a horrible name. I apologize everybody for that, but it generates lots of tests is where the the name came from there. So the idea is there's a whole bunch of different scenarios that are embedded inside of Cyclonus. And with generate, you can select different subsets of those and then run them one at a time on your cluster and collect a whole bunch of data. And then you'll get some nice data out that you can look at. It will show you trends and stuff like that. Let me make that a little bit more concrete. I know I have examples. Oh, I have an example right here. So we're going to run this in mock mode. So it's not actually going to use a cluster. That means it's going to go way, 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 way faster.
Yep. Yeah, by faster, he does mean like if you run a full unscoped generate, it takes like 20-30 minutes. Like at least some of the runs I've done. So
yeah, that might be something that we need to make faster at some point.
Well, I understand why though, because it's going through like 100 cases and it has to do them one at a time. So it makes sense why there's some length on that. Anyway, go ahead.
Yeah. So we'll just go through this output here for a couple minutes, I guess, and unless you think I'm getting off topic, Brian, you can yell at me. But we start off by showing you all the different options that are available. So like allow DNS. What this means is at least UDP 53, possibly also TCP 53. We add that to the network policies to make sure that DNS is always available. If you're hitting services by service name, that matters. I think if you're hitting pod IPs, it probably doesn't matter, but there's a flag for you to control that. Loopback, I don't know if loopback is the right term. Hairpin is something that I've also heard. Apparently that's an area of network policies that isn't 100% specified. It's kind of my understanding. If I'm wrong, please somebody let me know. But the idea there is what happens if a pod tries to ping itself. And sometimes, well, you can ignore that. If your CNI is failing tests because that's wrong, that's probably not useful data. So here's a flag to just ignore that and not worry about loopback. All the tests involve some kind of perturbation to the cluster, whether you're creating a network policy or you're creating pods or namespaces or deleting pods or changing labels on things. Here's a little bit of a time period between when you make Cyclonus do something to your cluster and you allow a few seconds for the CNI to implement that change before you start hitting it with traffic. I don't think this next one is super interesting, so we can skip that. Further down, here are all the resources that are created. So for this test case, we just have one server port 80, one server protocol TCP, and then, the 9x9 pods, 3 different pods called XYZ, 3 different namespaces called ABC. And then if we go further down, here's how we select all the tests that are built into Cyclonus. By the way, all the tests that are built in there are just things that I thought were interesting. If you're, coming into this from a CNI perspective, or you're not me, I guess, if you're anybody but me, you might think that there are other test cases that are interesting. So if it doesn't do what you think is interesting, I would love to hear about that. And we can start figuring out how to add some more test cases that are useful for what you're doing. So anyway, my point is it's just a bunch of test cases that I picked. They may or may not be useful to you, but hopefully, I did my best, but if they're not, then let's get some good ones in there. All those test cases are tagged by the different features that they're using, either features of network policy themselves, or if you're changing pods and changing namespaces and stuff like that, I think there's tags for those. I'll show you all those tags in a second. But what these do is they allow you to specify which test cases you do want to get by tag, and then which test cases you don't want to get by tag.
So if I wanted to start building in test cases for admin network policy, would I then go and extend those into the Cyclonus code base, and those would then become targetable like this, or would I need to look at that differently?
Yeah, I think that would be a good way to do it. I think so for admin network policy, you're going to have to, like, the engine right now doesn't support it, so the engine is going to have to be extended.
Right.
And then once you do that, then you can do Cyclonus analyze to see what network policies mean in an abstract sense. But yeah, once you want to start going over to CNI conformance, you'll need a test suite, and that's where you'll need to have Cyclonus start generating some some interesting test cases for admin.
Okay, so start with the engine, then go into generating test cases. Okay, that makes sense so far.
Yeah. Let's see, what else do we have? Yeah, I think that's all the interesting parameters. So then these are all of the resources that would be created. Obviously, if you're using a real cluster, then Cyclonus is going to actually create these. Since we're just doing mock, I just picked like a arbitrary bunch of IP addresses and stuff like that. And you can see we have that default label for network policies that was added like a year ago or something like that. I think Ricardo did that. I don't know if Ricardo's around. If somebody else did it, I apologize for giving your credit to Ricardo. And then here's all the test cases that we're going to run, broken down by the tags that are available. So we have a lot of different tags. You can see that some of them have 0, so we're going to hit none of the test cases that involve multi-port protocol. I don't know, some of these tags might be a little bit dumb or something like that. You know, it's a little bit idiomatic because it was mostly a one-person thing. So that's another thing that I'm excited about. You know, Cyclonus going upstream. Hopefully these things will become a lot less idiomatic and a lot more clear to everybody. SCTP, here's a really clear one. Okay, so we're not going to run any SCTP test cases right now. We're not going to run any test cases that have an IP block with no accept. On the other hand, we are going to run a bunch of test cases that cover egress. We're going to run some that have a deny all. So that's how to interpret that. And then this is the list of test cases that we're running. And you can see the list of tags for each test case. So I think this is just like a description that I just wrote in there. Let me go back to see what okay, yeah. So I called these test cases conflict because the basic idea was that I wanted to test that if you do, I think, a deny and an allow, that it correctly allows, but in all kinds of different cases. So I think that's what all these test cases are about. So here's all the test cases we're going to run. And then we start jumping into running those test cases. And those are executed one at a time. If you're on a real Kubernetes cluster, for this mock, it doesn't really matter. But yeah, this is a document that we saw earlier. This is what Cyclonus thinks your policy is. This is the K8s YAML for your policies. And, oh, sorry about that. Expected ingress, expected egress, combined, and then we get the kube results. Oh, okay, this is where I got that document from. I just ran it in mock mode where I just allow everything. Yeah. So then actual versus expected, everything where there was a block is wrong because I'm not running it against a real CNI. So then we get that set of results, and then we continue on to test case 2. So let me hop down to the end because it's just a bunch of different test cases. So down at the end, we have our summary table. You can see what failed and what passed. I think the only ones that passed are the ones that allowed all. Makes sense because, you know, my fake dumb CNI. And then it tells you what those results are. You can see I break things down by protocol. I think the reason for that was because at first we didn't have any SCTP or something like that. So I got all these failures that were actually not real failures. I can't remember why I did that, but that's what's going on here. You can see we're not running any tests on SCTP or UDP, so we don't have any success or failures there. So you see, you know, passed, failed, 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 failed. And then we break things down by tag. So this was kind of useful in cases where there were a couple of features that were missing from specific CNIs. And I think that it was pretty clear that like one feature would fail 100% of the time. And you could see, oh yeah, that feature is actually not implemented on the CNI that we're looking at. And then, yeah, like break these results down more by tag. I think John Schnacky, I don't know if he's on now, but he piped this output into JUnit and possibly also Sonobuoy. So that was kind of cool. Oh, there's some code for that. I don't know if anybody's using that.
Then that could go into that CA process we mentioned earlier. If you've got JUnit output at that point, that's pretty useful.
Yeah, hat tip to John for that. Yeah, so sorry, Brian, did I actually answer your question, or did I just get?
No, you did. I wanted a general overview of Generate, and then maybe looking at how we'd go about or starting to look at extending engine for ANP once we're done here.
Cool. All right, awesome. Yeah. What should we do next? Should we hop over to look at some of the code, or what do you think?
I think that'd be awesome. It helped to understand how you are writing these tests, and then I guess how I would look at extending engine to support ANP. make sure I don't completely clobber your vision and direction.
Yeah.
Yeah, and I'm very curious about like how you generate that expected metrics table.
Yeah, for sure. And then I just saw that Matt Merrick just pinged us. Let's see. Oh, so Matt's been using Cyclonus. Yeah, Matt's on Windows, and I've been talking to him every now and then. He's done some cool stuff. Hat tip to Matt for, I think you added some cool stuff into Cyclonus, and now you're looking at some more things using Cyclonus. So that's pretty cool. Over on Windows side. Yeah, would love to hear more about how that's working out for you. All right, so what do we got? We can talk about the engine, or we can talk about the generation first. Test scenario generation. Which one do you want to go into, Brian?
What do you think would make more sense from an order? Because we can always do another one of these, right? If we need to.
Yeah.
So which one do you think would make sense to go, if it makes sense to put them in order? If it
Yeah.
doesn't,
Yeah, that's a great point. Let's jump into the matcher first.
Okay.
So, secret sauce. What is the secret sauce of Cyclonus? I think that the matcher is, one of the 3 pieces of secret sauce for Cyclonus. In other words, I think it's really important, basically, to what we do in Cyclonus. So, at a high level, it's basically a model with some functions. It's not hitting Kubernetes directly. It's not like coupled to a CNI or something like that. It's just an abstract network policy model, and also an abstract traffic model. So traffic is like a request from a source to a destination that's on a specific port, specific protocol. So like, say you run curl or something from one pod, you shell into a pod and you run curl. You're in a pod, so that's your source. Your destination is whatever pod is hit by that traffic. Of course, if you do like port 443 TCP or something like that, there's your port and protocol. So we have a model of those 2 things. And then based on those things, we have a way to ingest Kubernetes network policies. We have a way to query our model. So like, okay, you have a bunch of network policies. Is it going to allow traffic? Is it going to block traffic? Which targets are affected by these network policies? And then I kind of talked about the Cyclonus analyze. So different ways to give you human readable explanations of network policies. Okay. This is probably
building a model of essentially the entire network policy state, like of that environment. That seems pretty complex.
Yeah, like I'm not sure if this is totally necessary. I guess it feels like you could just ingest a bunch of network policies and use the Kubernetes model, and then you can just query that at runtime to decide if something is blocked or denied. But I think what you can't do with that, and if I'm wrong about this, I would love to talk more about this with anybody, but I think the thing that you can't do with that is, what if you have a whole bunch of different policies on top of each other? What happens to those policies, right? So like, if you have a deny and an allow, the allow takes precedence over the deny, right? And you actually don't even have to think about the deny anymore if they're for the same target. And that's something that I can do pretty straightforwardly in this model.
Right.
I don't think that you can directly do that in the Kubernetes model. So that was one of the motivations for me to actually create a model.
Nice. Okay. Makes sense.
And yeah, I called it policy. I don't know. Maybe that's a good name. Maybe it's not. But we have policies broken down into ingress and egress. And the idea is that if you have 10 policies or 100 policies or whatever, and they have multiple peers, all that stuff, you jam all of those things into the same policy object in Cyclonus.
Okay.
And we have the concept of a target. This is pretty much the same as a network policy target. I think that's like, that is exactly what a Kubernetes target is, right? So your target is in one namespace, and then it's selected by namespace and pod labels.
Okay.
So we have the namespace that it's in, and then we have a label selector. Oh, I'm sorry. Yeah, a pod selector. in a single namespace. And then based on that, here's all of those peers in a Kubernetes network policy. And then we also attach the source rules that this came from. So for a peer matcher, you have all kinds of different things. You can match everything, like all peers, all pods, all IP addresses. You can match, let's see, this terminology gets a little bit, like, it makes my eyes bleed. So if anybody else feels the same way, I definitely don't blame you. Let's see. So what's the idea here? Port matcher.
Ports for all peers.
Okay, so we specify ports, but we don't specify the IP blocks or the pods. I thought I had more of these. Did I put them somewhere else? Does anybody know how to find all the things that implement an interface in GoLand?
You do like you're in GoLand. Never mind.
Yeah.
I was thinking like JetBrains or Vim.
Yeah. But yeah. So I do have more of these. So there's one where you can, yeah. So basically for all those different kinds of things that you can match, whether you just specify a pod label, you just specify namespace label, or you specify both, or you specify nothing, or you specify an IP block or an IP block with an accept. Like there's objects that represent all of those things explicitly. And one of the things that I really struggled with was if you specify like an empty list, right? An empty list of peers that has a certain behavior. And then if you add one thing to that has a different behavior, or I don't know, there's all those corner cases. I can't remember what they were, but I tried to make all those things explicit and like first-class citizens of like, if something is denied or whatever, or something is allowed, there's an explicit object that models that stuff. Maybe not really necessary, but definitely helped me to keep straight all those different corner cases and stuff. So then if we dive into this, let's see, we got the port matcher. You have all kinds of different matchers for ports and protocols and stuff like that. At the end of the day, what it all adds up to is we have a whole bunch of matchers under a target. And the semantics of network policies are, if you have nothing for let's see, what, God, I'm sorry, guys. If you don't select a pod with any target, then you allow all traffic, right? If you select a pod with a target, but you have no peers, then I think you block. But then if there's one or more peers and any of them matches your traffic, then you would allow that.
Right.
So that's what this comes down to for a target. That's why we have a slice of peer matchers here, and there's a lot of different things that implement this interface. So then we have this builder, which is pretty nasty code, but like the whole idea behind this is you take a bunch of Kubernetes network policies and somehow, some way, you just transform this into our abstract policy model. So this is where you see all those corner cases and it gets all hairy and stuff like that. I don't know if anybody really wants to dive into this too much. It you know, kind of writes itself, but then there's just all those corner cases that you have to watch out for.
Okay.
So then the other piece of Cyclonus's model is you have a model for traffic. Traffic source, destination, and protocol. And then I can't remember how exactly the port name and port work. I can't remember if we like resolve that with Kubernetes itself or something, but somehow you're going to specify the port. So port, protocol, source, and destination.
You mean the resolve? You mean like how you're going to get the underlying port number from a named port? Like you're going to query K8's API or something for that?
Yeah, I can't remember. Like there's some reason why I have both of these instead of just one or the other. I mean, you know what? Maybe I should have just used int or string or something like that. That's probably what I should have done. So there's just one field. But yeah, I don't know. Sorry that I can't remember why that is.
It's all right.
So then for our source, there's two options. From the point of view of network policies, right? Like your traffic can be coming from a pod, in which case you would go under internal peer. So then we'll capture the namespace labels, the pod labels, and the namespace, because all of those things can be targeted by network policy. Or you could come from outside the cluster, in which case we just have the IP address. Let's see, and it's the same thing for the destination. Yeah, so your destination can be inside of the cluster, so that's called an internal peer, or outside of the cluster, IP address.
Okay. So then that's maybe analogous to, say, an ingress policy if it was coming from outside the cluster. Or, well, technically an ingress policy can still be internal because pod to pod is still technically ingress traffic. But yeah, anyway, I get what you mean. Like a load balancer type policy.
Yeah, I'm not an expert in network policies, so if anybody can tell me if I'm right about this, let me know. But my understanding was that IP addresses were kind of like, I mean, you can use IP addresses for network policies inside of clusters, but like they're kind of more useful for things that are outside of clusters. I could be totally wrong about that though. So if I am, I apologize. So then building on that, if we combine the network policy model and the traffic model, we end up with this key function here, is traffic allowed or something like that. Where is it? Is allowed. This is being called by something else though, right?
It's traffic.
Here
right
we
there.
go. Yeah. Here we go. Yeah. So this is the key method there. If you want to know if traffic is allowed or not according to the model. So we're taking in that traffic, source, destination, port protocol. We check if ingress is allowed. We check if egress is allowed. And remember, you have to allow both of those from a network policy perspective for traffic to be allowed. But we don't just throw away that context immediately. So that's why we have this little allowed result here. And then, you know, later on, these two things are going to be combined. Oh, here we go. Direction result. Yeah, later on, we're going to combine these two to get the final output. All right, let me stop talking for a little bit. What do you think, Brian? What do you want to hear more about?
If we have 8 minutes. I don't know if that's enough to get into actually extending the engine, but yeah, it may not be enough time. But I don't know if you want to start looking at that now or save that for next time.
You know, I started hacking on this a few months ago, I realized, and like, but I don't think that it actually existed. So I saw that I have a branch that I haven't pushed to for a super long time. And I guess we could just take a look at this and see what's going on here, but I'm pretty sure that it's completely out of date with what actually ended up happening as far as the specification goes. Yeah, it's been like a year. It's been a year and a half. So this could be totally crazy.
So you were going for cluster network policy, you were thinking like, I think Andrea has the concept of a cluster network policy,
yeah.
right?
What's different between cluster and admin? Are those like totally different use cases?
Isn't CNP and Andrea a specific thing, or are there other CNIs that implement it? That's what I'm not sure on.
Okay. Yeah, we probably just got the name. Like we were talking about this in the SIG network policy working group, but maybe we just took the name from Andrea and we never really got into specifics about this. Either way, it looks like this it's so old that we probably should just not even really worry about this too much. I guess
still might take a look at it and just see what you had going there, because it might help me understand how to extend the engine a little better if I read through it, even if I don't use any of it. At least see what you were thinking when you started.
That's
be good.
What if we approach this from over here and like, so what does this do real quick? And I think one of the limitations of this, like for an admin network policy, you need to be able to do something that applies to all namespaces, right? With a single policy. That's not built into this model. I think that's probably one of the big limitations that you need to figure out. So you have the whole concept of namespace built directly into this. And this primary key thing is just used to track stuff in this map here, in this ingress map. But if you take a look at primary key, where does this get set? You can see that we put the namespace in the primary key, you know, so
I see. Yeah.
We'll have to have some way to add network policies, but then without a namespace. And I haven't kept up with admin network policy, but what does a target mean where you have admin network policy? Do you still have the whole concept of targets and isolation and stuff, or is that gone?
Yeah, I'm not sure. I'll have to look. Yeah, I'm not sure.
So I think that's a couple things. And then there's precedence, right? Actually, yeah, you're right. This was useful because I think I was starting to think about all these things over here. I just forgot that I thought about them. So what's the precedence between admin network policy and regular network policy? Do you do the admin first and then you do the network, the regular ones later?
Yeah, we have there was, I can't remember where it was published. I'll have to find the link later, but there's a link where we talk about precedence, where ANP is always going to, I think, end up being first, right? Because it's from the perspective of a cluster administrator. So you would expect that to have the highest rule of authority. But there's a series of 4 or 5, like, where one is more important than the other. I'll find that link and post it. Also, I was curious is if you were, with what you started there, was it for Entrea CNP that you were working on to extend Cyclonus for?
No, I was just like, I just had a little bit of extra time, so I was like, oh, everybody's talking about this. Let me just start hacking on it.
I gotcha. Okay.
That concept of precedences and stuff, that is 100% not in Cyclonus either, because before cluster network policy, or sorry, ANP, if anything allowed your traffic, it would be allowed. So you didn't have to worry about order. It didn't even matter what order the network policies came in or anything. If a policy allowed it, it was allowed. So there's no concept of precedences built into here. I guess that's probably the two big things, right? Getting something that works across multiple namespaces and is separate from namespace rules, and then getting precedence built into the model.
I sent the link to you guys in Slack because I'm not logged into StreamYard, if you want to post it to StreamYard.
Oh, yeah.
There you go.
Do you want me to bring that up? Let's see.
Or just useful for the recording later. But yeah, there's a priority field in the ANP spec defined as an integer value within the range of 0 to 1000 where rules with lower priority values have higher precedence. Regardless, so we'll probably have to build that priority field into your model. That's what I'm guessing.
Yeah.
Integer priority values were added to ANP. Yeah, so integer priority values were added to ANP to allow cluster admins to express direct and intentional ordering between ANP objects. Okay, so we have a little more control there. So good and bad.
Yeah. Yeah, that's a good one. So pass is a concept that's not in Cyclonus, and then deny is also a concept that's not in Cyclonus. So okay, those two things have to be added as well.
Okay, gotcha.
That's cool. Yeah, I like this. Sounds like a lot of good stuff that I remember people talking about. So it's awesome to see these are going to be coming out.
Also, I just realized they linked from not master, like some random commit ID. So let me just put the right link there. There you go. I think it's the same, but just so that people aren't going to some random commit ID link.
Yeah. Cool. All right. Yeah, I'll make sure to write that down in Slack. Those 4 or 5 things that we said need to be done or something like that. But
okay,
sounds like that's probably the first thing to do. And then after that, we can start thinking about what interesting test cases to generate. There's going to be some really interesting stuff. Like I told you that one of the sets of test cases that I did are what I call conflict. So now if you start thinking about all the different ways that ANPs can conflict with regular network policies, I think that's where stuff starts to get really interesting, especially from a user or admin point of view. Like,
sure. Yeah. I realize this is out of scope, but you would almost want, for a developer, they would want to know that they're writing a network policy that conflicts with an ANP policy before trying to push that upstream to their environment. I'm not sure what our intention is there. Are we going to allow them to apply it anyway and just ignore it? Or do we have maybe an admission control around that policy actually even being able to be applied? That's out of scope, I think, for this, but still, just now thinking that through, like, what's the developer experience for the downstream teams? It'd be interesting.
Yeah, I love it. So I guess from my point of view, like collecting all those use cases somewhere, I think would be super valuable, because I feel like there's this stuff that's kind of like locked up inside of Cyclonus, and now maybe the challenge is to like unlock that and connect that to those different things that you're talking about.
Yep. Yeah, maybe we could have some way for Cyclonus to help developers with that. Yeah, I see what you mean. Like, you write a network policy and then get back a conflict report, where the conflict report is going to include, hey, this network policy you're trying to apply conflicts with one of the admin network policies, so it is not going to work in this environment, or something like that. That would probably be pretty useful. Okay. Good stuff. Well, I'll look at extending the model, and then maybe we do another one of these in, we give it a week. Well, I guess we have Thanksgiving. Yeah, or a week.
Yeah, sounds good.
Go from there. Cool. Well, I really appreciate the time, and we'll be hitting you up on Slack.
Okay, thanks
All right, yeah.
everyone for watching.
Oh, Xinqi, we'll let you take over from here.
Yeah, thanks everybody. Thanks for hosting it, Xinqi, and thanks for getting this started, Bryan.
It's like, thanks for all the cool stuff. I really learned a lot from their talk today. So I'm so glad to be here. Okay, thanks everyone. See you guys later.
Bye.